This video will present solutions to the VCE 2024 Mathematical Methods Written Examination 2, Section B, Question 4. This question has us working with probabilities associated with the weight of airport luggage. Part A asks for a definite integral expression representing the probability that a piece of luggage is heavy, which is defined as being over 23 kilograms. I'm going to express this definite integral from 23 to 30 in terms of f of x, rather than wasting time and risking transcription errors by writing down the function's expression. For Part B, Part 1, the mean of x can be calculated by evaluating the definite integral from 0 to 30 of x times f of x dx, which I will do on my class pad. With that value of the mean found, we can now find the standard deviation of x in Part 2. I'm going to use this formula for the standard deviation of a continuous random variable. To evaluate this, I will use the definite integral already entered, changing the x to x squared and then subtracting 18 squared. With a result of 36 for the variance, the standard deviation will be the square root of that, which is 6. In Part 3, we are asked to perform a conditional probability calculation, finding the chance that a piece of luggage is heavy, with a mass exceeding 23 kilograms, given that its mass exceeds the mean of 18. I'm going to use a little copy and paste to construct this fraction in my class pad. Don't be tempted to assume that the denominator is equal to 0.5. The probability that a continuous random variable is greater than its median is always equal to 0.5, but this is not always true for the mean. The value of this fraction, and hence the conditional probability required, is 0.446 to 3 decimal places. This question now considers the number of pieces of luggage that travellers check in and the probability that they are heavy. To find the probability that a traveller checks in 2 pieces of heavy luggage, based on the information given, is 0.5, the chance they check in exactly 2 pieces of luggage, multiplied by 0.234, the chance that the first piece is heavy, multiplied by 0.234 again, the chance that the second piece is heavy. This probability is equal to 0.027378, which is equal to 0.027. As this is a show that question, writing down the relevant multiplication is necessary, and the value to greater than the accuracy given is not a bad idea as well. In Part C, Part 2, similar calculations need to be made to find firstly the probability that W equals 0, no heavy luggage is checked. There are 3 ways that W equals 0. Either the traveller checks no luggage with probability 0.1, or they check 1 piece, probability 0.4, and it is not heavy, probability 1 take 0.234. Or they check 2 pieces and neither are heavy. This can be evaluated on our class pad. With that found, the probability that W equals 1 can be found in 2 ways. One way is to subtract the known probabilities from 1, and the other considers the 2 ways that 1 piece of heavy luggage can be checked, as either 1 of 1 piece, or as either the first or the second of 2 pieces of luggage checked. Part D now looks at the number of heavy pieces amongst random samples of 35 pieces of luggage. Part 1 asks about the probability that the sample proportion p hat is greater than 0.2, which I will calculate by considering y greater than 7, where y is distributed binomially with n equals 35 and p equals 0.234. The relevant probability from the binomial distribution of y is y greater than or equal to 8, which can be found on my class pad using the interactive distribution menu. In Part D, Part 2, we need to know the mean and the standard deviation of p hat so that we can find the probability that it lies within 1 standard deviation of the mean. The mean of p hat doesn't require much calculation. The standard deviation will be equal to the square root of p times 1 take p over n. So, the probability we're interested in is p hat between 0.1624 and 0.3056. This is equivalent to the probability of y between 5.684 and 10.696. Because of the discrete nature of y, this means we need to use the binomial distribution to calculate the probability of y between 6 and 10 inclusive. Part E, Part 1 asks for the calculation of a confidence interval for p, a routine job for my ClassPad statistics app. From the Calculate menu, choose Interval and select a 1 proportion Z interval. A 90% confidence interval based on a sample count of 10 out of 50 is from 0.107 to 0.293. Part 2 of this question introduces a second 90% confidence interval that is wider than the one found in Part 1. The reason why this confidence interval is wider, given that it has the same confidence level, is that the standard deviation, as determined by the square root of the count y over 50 times 1 take y on 50 over 50, must be greater than the standard deviation from Part 1, which is the square root of 0.2 times 0.8 over 50. I'm going to enter this inequality into my ClassPad and solve for y. The ClassPad solution is for y strictly between 10 and 40, and so, because of the discrete nature of things, the minimum number of luggage pieces is 11 and the maximum number is 39.